Hello everyone, welcome you all to the very first live session of the course Fundamentals of Manufacturing Process. The instructor of this course is Professor D.K.Dwivedi and I am the teaching assistant of this course. Myself is Abhishek Maurya. I am research scholar at the IIT Madras. So here we are going to solve problems which is of the 0th assignment. So let's get started. The first question is like that: in oxyacetylene welding, the color of oxygen cylinder is. So as we know that I am sure that all of you have somewhere seen the oxyacetylene welding because it is very common and it is used to join the metals. And if you see this drawing, we can clearly see that here we have two pieces of the metals, like these two are the metals, and we are trying to join these two metals using the oxyacetylene welding method. And this one we can see, this is a filler rod, this is the torch or welding torch, and this is the filler rod. So I would like to tell very briefly about the oxyacetylene welding. Basically, in the purpose of welding is to join two metals, and for that, first what we do, we try to melt the material locally, and then we try to put some filler material between the gap of those two materials, and then we let it the solidified so that our metal get our both material get jointed. So if we see specifically about the oxyacetylene welding, here the heat is generated by the chemical reactions. We know acetylene is an good source of fuel, and if it reacts with oxygen, then it will produce lots of heat, and during this process CO2 and H2O get produced. And since it is very common process, you might have definitely seen somewhere, whether in the workshop or in the automotive repairing shop. So this is very common. There is some color code given to the cylinders, like here we have we are using two cylinders. One is the oxygen and one is the acetylene, and as per the Indian standard, the color for the oxygen cylinder is black, and for the acetylene it's maroon. So here in the diagram you can see. So the correct answer for this question will be the where it is being asked that the color of the oxygen cylinder, it will be the black. So black will be the correct answer. Now let's move to the next question. The question is like that: which of the following is included in the machining process? So first of all, we should know what is the machining process. Broadly, if I will tell, it's a process where the metal is being removed. So here we are getting few options like coating, extrusion, soldering, drilling. So let's see one by one to all of these options. If we see what is the coating, basically in coating, a thin layer of material is deposited on another material. So in order to get some specific desirable property, basically we can see here we have substrate material and This is the material which is getting deposited on the substrate material, and after that the whole substrate material is getting covered with the coated material. This is the coating process. So if we see the definition, machining process is the metal removal process. Basically here material is not being removed, so this is not a machining process. Let's go for the next process, extrusion process. Extrusion process is a kind of metal forming process. What we do here, we have die. Here we have die, and here we have punch or ram, and in between the die and the ram we have our billet material, and from the front end of the die we have opening of desired shape. From the extrusion process we are able to manufacture axis symmetric products like pipe, rods. So we put the material in between the die and we try to push it by the ram or punch, and because of the punch pressure material comes out from the opening, where it takes the shape of the opening. So this is the roughly overall the process of the extrusion. So let's see whether it is machining process or not. Again we can see that here the material is not being removed, so it is not a machining process. Let's come to the soldering process, which is the third option. It is very common process. We all have seen soldering process is being used to attach component in the PCB boards like capacitor, resistor. So all these are being attached on the PCB board with the help of the soldering, where we use some filler material, and we provide some heat and we put component on the board and it gets joined. Here also we can see there is no material is being removed, so this is also not an machining process. Let's come to the drilling process. Here basically drilling is the process where we have our base material and we try to make a hole inside that material, and this is the tool. This tool rotates and it has some specific geometry which we will see later in this course, and because of that special geometry it starts removing the material from our base material, and the material which comes out in the form of this is called chips. So if we see the definition of machining process, metal removal process, here metal is being removed in the form of chips. So we can say drilling is the machining process. So this will be the correct answer for this question. Let's move to the next problem. The question here it is being asked like poor permeability of molds and leads to defect. Basically this is the problem of casting, and these are all like cold shut, scap, cuts and washes, blowholes. These are the uh, defects occur which during the process of the casting. So we will see one by one, and let's talk about the permeability. In the sand casting, uh, I would like to explain with the diagram. So something like that. uh, our aim is to produce some component with the help of the molten material. Here we have molten material, and we are pouring it inside a die. Basically this is made up of sand. Here I have shown dotted, I have shown the sand with dots. This is the sand, and these are the this is the final component which we are looking for. We should get after the solidification of after the solidification of the molten metal. This is this is called the sprue. This is called riser. This is called pouring basin. So here we can see uh, sand is this mold is formed with the help of sand, and the permeability is specifically focusing on the type of the sand. Basically we can say it is ability of the sand to allow the escape gases through it during the casting process. Basically metals comes inside the mold, and during the solidification process lots of gases is being released, and which should come out of the mold. Otherwise it will have many defects, and we will see because of this which defect is going to occur one by one. So first come to the cold shut. What is the cold shut? Cold shut happens because of when our metal gets solidified inside the mold, and if we have very thin boundaries, like here we can see the material starts the solidification starts from this side as well as from this side, and with the time temperatures keep on decreasing, and at the end what happens when these two regions meet together and when metal reaches there, it doesn't have sufficient temperature to get fused properly, and because of this cold shut occurs. So this is kind of defect, but here the sand permeability has to play no role, so cold shut will not be the correct answer for this question. Now the second option is escape. uh, we can see um, the material has not basically this is the component region which is formed from the molten metal, and this is what we don't desire. We wanted a solid block of metal, but because of improper ramming is the process uh, during the mold preparation, and because of improper ramming this kind of defect occur. And uh, here sand permeability has no very minimal role, so this will not be a correct answer for this question. Now we see third option, cuts and washes. Yeah, it happens because of when we pour the metal, it starts flowing through the gates. This is the gate region, and it starts filling the mold region here inside these. Ideally, we want all material should go here, and it should get filled inside the whole mold without disturbing the gate passage. But sometimes it doesn't happen. When when molten metal flows through the gate, it also removes some sand material or molding material from the gate, and this is kind of erosion where the flow of metal takes away the molding material, and because of that the sand cuts and washes occurs. But this is a defect, but it has nothing to do with the permeability of the sand, so this will also be not the correct answer. Now let's see the last option, blow holes. Here it is the schematic of the final ingot which we get after the solidification, and I told that permeability of the mold is defined, permeability of sand is defined as the ability of the sand to escape the gases or air inside the mold. And if we have poor permeability, basically sand around, we will have sand around this kind of setup we can assume, like it is surrounded by the sand, and whole the molten metals comes here, and during the solidification gases will try to escape out of mold. But if our sand will not allow to escape the gases or air from the molten metal, then what will happen? They will get entrapped here, and even after the solidification they will remain trapped inside the ingot, and which is not desirable at all. So this is the defect which is caused by the poor permeability of the molding sand. So this will be the correct option. Blowholes will be the formed because of the poor permeability of the sand. So this fourth is the correct answer for the problem number 3. Now let's move to the next problem. The question is, gas welding is a type of, first option is material addition process. We already seen that in the first question we have seen in the oxyacetylene welding, we were trying to join the two material with the help of filler material. So basically we were trying to join the material, additionally we were adding the filler material. So this will be the correct option for this question, but let's see uh, let's also see the what other options are saying. Second option is material removal process. It is definitely not correct, because the aim of the welding process is to join two materials. So anyway, no material will get removed, and it's a constant mass process. When we Since we are joining two metals, and uh, filler material will also being used in the gas welding, so mass will not be constant. There will be some increment of mass, so this will not be the correct. Therefore the first option will be the correct, and last option will not be correct, because remaining 2, 3 and 4 are incorrect. So the correct answer for this question will be the material addition process. Let's move to the next problem. Yes. Problem 5 says induction hardening is based on. These are the options. First one is transformation hardening. Next one is surface layer deformation. Next one is the built up layer. Fourth one is the chemistry modification. So first of all, let's see what is induction hardening process, or in simply, first let's talk about what is the hardening process. Hardening process is the process where the properties of the metal is improved. Which property? The hardness of the material. So how we can achieve the better hardness? So if I will talk about the induction hardening process, first we have the workpiece material, and we are trying to heat the material locally. This is the inductor coil which is surrounding the workpiece material, and first we are trying to locally heat the material. Up to what temperature we will heat? It is a very specific temperature above which the phase of material gets changed. So if we talk about ferrous metal, then it should be above the austenizing temperature. So material is locally heated above the austenizing temperature, and after that what happens? It is rapidly being cooled, and because of rapidly cooling, the phase of material changes to another phase which is called a martensite, which is very hard in nature. We can see here the water nodules are there, and these water nodules rapidly cool down the locally heated material, and this locally heated austenite material get transformed into the martensite. Please, as of now, don't worry about the names of this phase. Just try to understand that martensite, we are trying to form the martensite on the surface of the material, so that hardness of the ferrous material on the surface get becomes higher. So this is what happens in the induction hardening. We are trying to improve the strength or hardness of the material with the help of phase transformation. So first option is saying that induction hardening is based on transformation hardening. So since here phase transformation will happen, so this will be the correct option. Let's go for the other options, whether they are correct or not. Surface layer deformation. During the whole process, we haven't tried to deform the anyway the workpiece, so second option will not be correct. Let's go about the build third option, build up layer. In build up layer processes, uh, the we try to improve the property of the material by depositing some another material over the existing material, or we try to change the property of the base material by putting a thin layer of material over it. So here we are not doing any such process, so third option will also be not the correct option. Let's talk about the fourth option, chemistry modification. In induction hardening process, we not at all try to change the chemistry of the material. Earlier also the material was ferrous material, and later on also it was ferrous material. We haven't changed any chemistry of the material, although we have tried to change the phase of the material, but by keeping the chemistry or the chemical formula same. So this option will not be the correct option. The only option will be correct, it will be the transformation hardening. So this was all we have to solve in the zeroth assignment. So if any of you have doubt, please feel free to ask questions. Otherwise, we will end this live session here itself. Thank you.